I want you to picture two men standing next to each other. Both of them are 70 years old, same age, same number of decades behind them. But that is where the similarity ends. The first man, let's call him Steve A., is on a beach in Florida. He is pulling a kayak down to the waterline, moving with a kind of easy, unhurried strength that most people associate with someone 20 years younger. His mind is sharp. His posture is solid. He is not thinking about his medications or his next doctor's appointment. He is thinking about the water and the horizon and what he is going to do with the rest of his day. He is not managing his decline. He is living his life. The second man, Steve B., is struggling to get up from his couch, not because of an injury, not because of a single catastrophic health event, because after decades of quiet, invisible biological erosion, his muscles have wasted to the point where standing up from a soft surface requires real effort. His memory slips in and out. The mental sharpness he had at 50, at 45, at 40, it is gone, replaced by a fog that never fully clears. He spends his days managing a list of medications and his nights worrying about becoming a burden to his children. Now here is the question that most people never ask directly enough. What actually separated these two men? Because if you ask most Americans, they will tell you that Steve A. got lucky. Good genetics, the right parents, the right lottery of biological circumstance. And Steve B. just got the bad draw. The decline was inevitable. Aging is aging. You cannot fight it. That assumption is wrong. And the science that proves it wrong is not new, not fringe, and not complicated. Research into longevity and biological aging has now established with remarkable consistency that somewhere around 70% of how you age, whether you are the man on the beach or the man on the couch, is determined by modifiable lifestyle factors, not by the genes your parents handed you. Genetics loads the gun. The way you live pulls the trigger. The tragedy is not that we age. The tragedy is that most of us are accelerating our own decline without knowing it, through patterns so normalized by modern American life that they do not register as dangerous until the damage is already done. Stay with me through the next 20 minutes, because what I'm going to walk you through is not a motivational speech about willpower or discipline. It is a specific, evidence-based explanation of what is happening inside your body as you age, why one of the most well-researched and inexpensive supplements on Earth has emerged as a significant tool in the science of healthy aging, and precisely how it works at the cellular and physiological level. By the end of this video, you will understand something that most people, including most physicians in routine clinical practice, have not fully connected. That creatine is not just a supplement for athletes in their 20s. It is a molecule with profound and growing evidence for protecting muscle, bone, brain, and metabolic function across the decades of life when those systems are under the most sustained biological pressure. Let's start with the most important thing to understand about how aging actually damages the body. Because most people think of aging as a gradual, uniform slowdown. Everything just gets a little worse, a little slower, a little weaker, at roughly the same pace. That is not how it works. Aging has specific mechanisms, specific physiological processes that drive the decline, and understanding them changes how you think about what can be done to intervene. The most consequential of those mechanisms, the one with the widest reach into your overall health, your independence, your cognitive function, and your risk for virtually every major chronic disease, is sarcopenia. Sarcopenia is the medical term for the age-related progressive loss of muscle mass, strength, and functional performance. It is not simply getting weaker the way you might after skipping the gym for a few months. It is a systemic biological process involving changes in muscle fiber composition, deterioration of the neuromuscular junctions that connect your nervous system to your muscles, shifts in muscle protein turnover that favor breakdown over synthesis, declining anabolic hormone levels, increasing low-grade systemic inflammation, and the accumulation of senescent cells, aging cells that have stopped dividing but remain biologically active in damaging ways. Sarcopenia typically begins its measurable progression in the third and fourth decade of life. Most Americans start losing muscle mass at a rate of roughly 3 to 8% per decade, beginning in their 30s, with the rate accelerating significantly after 50. Researchers estimate that by 2050, over 200 million older adults worldwide will be living with clinically significant sarcopenia. And the consequences extend far beyond physical appearance or athletic performance. Reduced muscle mass is independently associated with increased risk of falls and fractures, reduced insulin sensitivity and higher risk of type 2 diabetes, slower recovery from illness or surgery, impaired immune function, and, this is the connection most people never make, accelerated cognitive decline. A comprehensive body of research investigating the relationship between sarcopenia and cognitive function has found that cognitive impairment appears in roughly 40% of individuals diagnosed with sarcopenia, compared to 25% of those without it. The muscle-brain axis, the bidirectional biological communication network between your skeletal muscle and your central nervous system, means that what happens to your muscles does not stay in your muscles. The decline is coupled. Lose the muscle, lose the brain. And conversely, protect the muscle, and you are simultaneously protecting cognitive function through mechanisms involving myokines, signaling proteins secreted by active muscle tissue that cross the blood-brain barrier and support neuroplasticity, neurogenesis, and the maintenance of executive function across decades. This is why the question of how to protect muscle mass as you age is not a fitness question in the narrow gym culture sense. It is a longevity question. It is a quality of life question. It is the question that determines whether you are Steve A or Steve B at 70. And it is precisely where creatine enters this story in a way that is supported by a depth and breadth of clinical evidence that most people have never been exposed to. Creatine is a small molecule that your body already produces. Your liver, kidneys, and pancreas synthesize roughly 1 to 2 grams of it daily from 3 amino acids: arginine, glycine, and methionine. You also obtain creatine from food, primarily red meat and fish. The supplement version is simply creatine monohydrate, the same molecule, manufactured to pharmaceutical-grade purity, available in powder form for pennies per gram. It is one of the most extensively studied nutritional supplements in the entire scientific literature. And while it has been known for decades as a performance enhancer for competitive athletes, the research of the past 15 years has revealed something far more important for most Americans: its role as a direct countermeasure against the specific biological mechanisms of aging. Here is the foundational mechanism. Inside your muscle cells, creatine combines with phosphate to form phosphocreatine. Phosphocreatine is your cell's rapid energy buffer, the reserve system that regenerates ATP, your primary cellular energy currency, during moments of high-intensity physical effort. When you contract a muscle powerfully, your body burns through available ATP in seconds. Phosphocreatine is what allows rapid ATP regeneration so that the effort can continue beyond that initial burst. As you age, your muscle phosphocreatine stores naturally and progressively decline. Your cells become less capable of producing and sustaining the rapid energy output that high-quality movement requires. The result is not just reduced athletic performance. It is reduced capacity for the kind of movement stimulus that your muscles need to maintain their mass and structural integrity. Less intensity means less stimulus. Less stimulus means more sarcopenia. Supplementing creatine directly reverses this cellular energy deficit, and in doing so, It preserves the capacity for the training quality that drives the muscle preservation response. But the mechanism goes considerably deeper than energy buffering. When intracellular creatine levels are increased through supplementation, research shows reductions in muscle protein degradation, increased activation of satellite cells, and improvements in whole-body lean tissue mass. Satellite cells are the muscle stem cells responsible for repair and regeneration. They are what your muscle activates after a demanding training session to rebuild damaged fibers stronger than they were before. As you age, satellite cell activity naturally and significantly declines. Creatine supplementation appears to partially restore that activation, creating a more favorable cellular environment for muscle protein synthesis and structural renewal, even in aging tissue that has already experienced meaningful decline. The clinical evidence for creatine's impact on aging muscle mass and strength is not speculative. It is backed by multiple systematic reviews and meta-analyses, examining thousands of participants across controlled trials. A 2024 meta-analysis incorporating 20 separate studies with over 1,000 older adult participants found that creatine intake combined with resistance training significantly improved maximal strength compared to training with placebo. That is the most direct clinical measure of functional muscular capacity, the measure that predicts independence, fall risk, and ability to perform the basic physical tasks of daily life more reliably than almost any other single metric. And a comprehensive review of the evidence found that creatine monohydrate at 3 grams per day or more, combined with resistance training, is a viable and meaningful intervention for improving strength, lean mass, regional muscle size and density, and functional ability in older adults. 3 grams per day. The cost of that daily dose, using standard creatine monohydrate powder, is approximately 15 to 20 cents. A monthly investment of under $6 that the clinical literature supports as genuinely protective against one of the most consequential biological processes in human aging. Now let's talk about bones. Because the muscle conversation and the bone conversation are more tightly connected than most people realize, and creatine's effects on bone health represent one of the more compelling areas of emerging research in the aging literature. Osteoporosis affects approximately 10 million Americans, with another 44 million having low bone density that places them at elevated fracture risk. For older adults, a significant fracture, particularly a hip fracture, is not simply a painful and disabling event in the short term. It is associated with dramatically increased mortality risk in the 12 months following the event, particularly in men over 70. A hip fracture in an older man carries a 1-year mortality rate of around 30%. This is not a minor health event. It is frequently a life-ending one. The connection between muscle and bone is both mechanical and biochemical. Mechanically, muscle contractions place dynamic stress on bone, and bone responds to that mechanical loading by maintaining or increasing its mineral density. When muscle mass and strength decline with age, the mechanical loading on bone declines in parallel. Less loading means less stimulus for bone maintenance. Bone mineral density falls alongside muscle mass in a syndrome researchers now call osteosarcopenia, the co-occurrence of both conditions in the same aging individual, which carries a significantly higher risk profile than either condition alone. Creatine's effect on muscle mass and training performance therefore carries an indirect but meaningful protective effect on bone, simply by preserving the mechanical stimulus that skeletal tissue requires to maintain its structural integrity. Beyond the indirect mechanical pathway, research has found evidence of more direct biochemical effects of creatine on bone biology. Studies have found that creatine supplementation influences the activity of osteoblasts, the cells responsible for new bone formation, and may affect bone mineral content through mechanisms that are still being characterized in the literature. The evidence here is less uniformly consistent than in the muscle domain, and researchers have noted meaningful variability across studies. What is consistent across the evidence is that the combination of creatine supplementation with progressive resistance training provides more robust protection against the compound decline of muscle and bone than resistance training alone. A finding that has practical implications for how older adults should approach both their training and their supplementation simultaneously. Creatine monohydrate is the form supported by the overwhelming majority of the research. There are dozens of proprietary forms marketed under various brand names: creatine hydrochloride, buffered creatine, creatine ethyl ester, creatine nitrate, all priced significantly higher than monohydrate, and none of them supported by evidence of superior efficacy in aging populations. The marketing for these alternative forms is aggressive and sophisticated. The science behind them, compared to monohydrate, is thin. Use creatine monohydrate. Buy the least expensive, pharmaceutical-grade version you can find from a reputable manufacturer. The molecule is the molecule. The brand premium is marketing. Hydration deserves explicit mention because it is the one practical variable that most affects tolerability, and the absence of which generates most of the minor side effects that lead people to attribute problems to the supplement itself. Creatine draws water into muscle cells osmotically. This is actually part of the mechanism by which it works. The cellular hydration it produces contributes to the anabolic signaling environment in muscle tissue. But it does mean that inadequate overall water intake can produce muscle cramping and headaches that have nothing to do with creatine being harmful, and everything to do with not drinking enough water alongside it. Aiming for consistent daily water intake in the range of half your body weight in ounces is a reasonable target. If you weigh 180 pounds, that is approximately 90 ounces, about 11 cups spread across the day. Not a dramatic change for most people. Genuinely sufficient to prevent the minor dehydration effects that give creatine an undeserved reputation for causing cramping in some users. One specific population deserves particular attention within the aging conversation, and it is one that is often underserved by the fitness-oriented framing that most creatine content takes. Older adults who do not eat red meat or fish regularly, including vegetarians, vegans, and the many older Americans who have reduced their animal protein intake for cardiovascular or digestive reasons, have significantly lower baseline creatine stores than their meat-eating counterparts. Dietary creatine comes almost exclusively from animal-sourced foods. People who do not eat those foods rely entirely on endogenous synthesis, which has a biological ceiling well below what supplementation can achieve. For this population, the benefits of creatine supplementation are not simply additive on top of a dietary baseline. They are filling a genuine deficit. Multiple studies have found that the cognitive and physical performance benefits of creatine supplementation are more pronounced in vegetarians and vegans than in omnivores, precisely because they are starting from a lower baseline. If you have been eating plant-based for years and have been experiencing the fatigue, cognitive fog, and training inconsistency that you assumed were simply features of aging, low creatine stores are a plausible, correctable, and frequently overlooked contributing factor. Here is the practical synthesis of everything we have covered, because information without a clear action path is just noise. The protocol for an American adult over 40 who wants to use creatine as part of a genuine aging countermeasure strategy is straightforward. 5 grams of creatine monohydrate every day at a consistent time with adequate water, without a loading phase, without cycling on and off, without purchasing a more expensive form. Pair it with 3 to 4 sessions per week of progressive resistance training built around compound movements. Maintain adequate protein intake. Your body weight in pounds multiplied by 0.7 gives you a daily gram target that most people find practical. Prioritize sleep, because growth hormone, the primary anabolic hormone that creatine's training performance enhancement supports, is predominantly secreted during deep sleep, and chronically poor sleep undermines the entire biological chain that creatine is supporting. That is the foundation. Not complicated, not expensive, not requiring radical lifestyle restructuring. What it requires is consistency. Because the benefits of creatine supplementation are not acute, they are cumulative. They build quietly over months and years in the background in ways that do not show up on a single morning's mirror check, but show up unmistakably in the trajectory of your physical and cognitive function over a decade. Let me bring this back to where we started. Steve A. and Steve B. Two men at 70. One living, one managing. And the assumption that most Americans make, that the difference between them was written in their DNA, that the trajectory was fixed from the beginning, is not what the science shows. The science shows a 70% modifiable story. It shows that the decisions made in the 40s, the 50s, and even the 60s about how to move, how to fuel the body, how to protect the muscle and bone and brain that make independent, capable, engaged life possible. Those decisions are the difference. Not luck, not genetics. Decisions. You are watching this video because you are someone who makes deliberate decisions about your health. The way you make deliberate decisions about your finances, your career, and the things that matter to you. You do not wait for a crisis to start paying attention. You build the structure before you need it. And the structure that the science points toward for healthy aging. The combination of consistent resistance training, adequate protein, and daily creatine supplementation as one of the most evidence-supported and underutilized tools in the aging prevention toolkit is available to you right now, today, for less than the cost of a daily cup of coffee.